Hello everyone. In this video, we are going to talk about why we need inheritance. So with the help of inheritance, we are able to increase the reusability of our code, and our codes will look much more clean, and we don't have to write piles of codes. We can replace it with less lines of code instead. Okay? And plus, it can help you to avoid the duplication of variables and methods being repeatedly created over and over again in different classes. Okay, for example, if I have to create cat, dog, fish, those three classes without the inheritance, suppose that these are the requirements that are given for creating dog, cat, and fish classes. So in order to include all those attributes and actions, without the inheritance, the only option that I have is declaring each of those attributes and methods one by one in each of those classes one by one. In each of those classes, I have to declare each of those variables and methods one by one. In the cat class, I would end up writing this many lines of codes. Okay. And so same in the dog class. In the dog class, I will end up writing lots of lines of codes. And same with the fish class. Okay. And as you can see, in each of those classes, we do have common variables and methods, such as name, breed, age, size, okay? And all those variables are common in all of those three classes. And we also have the methods that are common. Eat, move, toString. Those eat, move, toString methods are common for all of them. And in addition, those classes, they also have their unique methods as well. Okay. Without the inheritance, I just have to write each of those common variables and methods one by one in every single one of those classes. And suppose that I still have to create five more animal classes like calf, dolphin, or any other animal classes. And then in order to include all those attributes and those methods, I still have to write them one by one without the inheritance. Okay, which means you are repeating the same set of code fragments over and over again in each of those objects. So in order to avoid the duplication of those variables and methods in each of those objects over and over again, then what we can do is we can apply the inheritance. So when you apply the inheritance, all you have to do is first create a parent class which will be containing all the common features of the cat, fish, and the dog. You create those variables and methods just one time, and any other animal class, they can just inherit it from this base class, from this animal class. Okay. So that way, in the cat class, in fish class, in the dog class, you do not have to repeatedly create those variables and methods over and over again. You just have to add the additional unique methods or variables that are needed in each of those classes. Other than that, those common variables and methods, we can just inherit them from the parent class. Okay. So as you can see, the benefit that inheritance giving here us is we will have less and less lines of codes to write. Our codes will be much more cleaner. Okay. And plus we can reuse those variables and methods of the parent class. We just declare them one time and we can reuse it as many times as we want in multiple classes. Okay. If I have to create 10 more animal classes, I don't have to declare those variables and methods again. I can just inherit the animal class to other classes so that the other classes, they will also have all those variables and methods. And another advantage of the inheritance is, you see, if you need to make change to any of those variables, let's say you need to add additional variable that is common for all classes, or you need to add some additional method that is common for all the classes, then all you have to do is just go to one place, go to the parent class to add them. Okay. If you did not have the inheritance, for example, if you need to add the sleep method for the cat, dog, fish, and any other animal classes later on, then you would have to go to each of class one by one to add them. But with the inheritance, if it is common, then you can just add it in the animal class and it will be inherited to all the child class as well at the same time. So that is the benefit of inheritance. It is maintainable, it is reusable all those variables and methods will become reusable into the other objects as well. Okay, and plus the execution will be much more faster as well, because you will have less lines of codes. Okay, and your codes much more understandable and clean. So that is the benefit of inheritance. That's why we need inheritance. We are going to talk about the super keyword. The super keyword, it refers to an object's superclass instances. Okay, we can use the super keyword to call the superclasses constructor. As we previously stated, the constructor of the parent class, it cannot be inherited to the subclasses, but the subclass has to call the parent class's constructor. Even though the parent class constructor cannot be inherited to the subclass, but the subclass, it has to call the parent class constructor. And if the parent class has a default constructor, then the child class calls it implicitly. Okay, whenever the parent class has default constructor, then the child class will call it implicitly. Otherwise, if the parent class has a constructor that is passing parameter, then child class has to call it explicitly. And in order for child class to call the constructor explicitly, child class has to use the super keyword. Just like when you use the this keyword, it is calling the current classes, instances, instance variables, methods, and constructor. When you use the super keyword, it will be calling the instance variables, instance methods, and constructor of the superclass. Okay, and if you need to call the constructor of the superclass, then after the super keyword, we need to give the parentheses, just like we give the parentheses after the this keyword in order to call the current classes constructor. Okay. And here is an example of the super keyword. Suppose that this is the animal class that we created, and we also added a constructor in order to be able to set all the instances of the animal. That way, whenever the animal object is created, all the instance will be set as well. The name, breed, size, all of that. And this animal class right now is the parent class. If the parent class contains a constructor that is not default, then it means that child class, it has to call it explicitly every single time. Otherwise, the child class will get compile error. And in order for child class to call the parent class's constructor explicitly, the super keyword has to be used. And if the parent class constructor is passing four parameters or 3 parameters, then the child class, when it calls the parent class's constructor, it has to provide 3 or 4 arguments. Okay. Without using the super keyword, we will not be able to call the parent class constructor, especially if the parent class constructor is not default. If the parent class constructor was default, the super keyword would be given implicitly. Super keyword would be placed here implicitly only if the parent class constructor was default. If not, then in the child class, you have to call the parent class constructor by yourself by using the super keyword. We are going to do practice with the super keyword. So here we have this parent class animal that is given that we created in our previous videos. In this animal class, we have added all those instance variables that are needed for all the subclasses. And I want to be able to set those instance variables as soon as any of the animal object is created. Which means we will need a constructor, because constructor gets executed whenever the object is created, and we can also use the constructor to set those instance variables at the same time. Okay, so therefore if I declare a constructor here, I will be able to set the instance of any animal object. Which means we can also generate the constructor by using the IntelliJ shortcut. And in the constructor, I would like to be able to set name, breed, age, size, all those instances. And once you click this OK button, you see now the parent class has a constructor. But if the parent class has a constructor, then it means the child class has to call it. Okay. Earlier, when I did not create this constructor, parent class had the default constructor. Before we create this constructor by ourselves, the parent class had the default constructor. That time the child class was not giving me any compile errors, because parent class's default constructor would be called by default in the child classes. But when you create a constructor that is not default in the parent class, that means the child classes, they cannot call it, they cannot call this constructor by default. It cannot be called implicitly in the child classes. Child classes, they have to call those constructors explicitly. Okay. So therefore, if you do not give the super keyword to call the parent class constructor explicitly in those child classes, you will be getting this compile error in the class header. Okay. And whenever I create the cat object, I also want to be able to set the name, breed, age, and size of the cat. And when I create the dog object, I want to be able to do the same. The name of the dog, breed of the dog, age, and size of the dog should be set as well. So therefore, we still need a constructor in this cat, dog, and fish classes in order to be able to set their instance variables. Okay. So therefore, in this cat class, I can create a constructor, and the constructor name has to be cat. Okay. Because every single constructor's name has to be same with the class name. That is also one of the reasons why the parent class's constructor cannot be inherited to the child class. Because parent class's constructor is animal, and in this cat class, we cannot have a constructor with the name animal. The cat class's constructor has to be cat. Okay? And when I create this constructor, I want to use this constructor to be able to set the name, breed, age, and size of the cat. So which means I still need to pass those parameters in this constructor. Okay? So what that means is that right now, if you have to create a cat object, you have to use this constructor, and you need to provide the name of the cat, breed, age, and size of the cat. Okay. So now, next step, I need to make sure that all those arguments will be set to the instance variables. So we could have called it instance variable by using this keyword, and then initialize them, and then assign the argument to the instance variables. But you see, this step has already been repeated in this parent class. Okay, in this parent class's constructor, this step has already been repeated. So whenever the parent class contains a constructor that is not default, it indicates that the child class, it must set those instances that the parent class constructor is setting. And since this code fragment is already given in the parent class, I don't have to repeat them. I can just call at line 6. I can just let the child class to call the parent class constructor. And plus, it is a must anyway. For child class, it is a must to call the parent class constructor. And in order child class to call the parent class constructor, we need to use the super keyword. Okay. And when you use the super keyword to call the parent class constructor, you also need to provide all the arguments that are needed to call the parent class's constructor, that specific constructor of the parent class. So as you can see in this parent class right now, we only have one constructor that is passing 4 parameters, which means in order to call this constructor, we have to provide 4 arguments. First argument will be the name, second argument will be the breed, then age, then size. And those parameters are also the ones that I want to set for the name, breed, age, and size. So therefore, now I can just pass those parameters: the name, breed, age, and size. You see? Now, this child class, it is calling the parent class's constructor to set the name, breed, age, and size. So that way we don't have to repeat those code fragments over and over again in the other subclasses as well. Okay? And since the calling the parent class's constructor is a must for the child class, IntelliJ, it will also give you the shortcut, which allows you to call the parent class's constructor automatically. So in this child class, when it comes to calling the parent class's constructor, you can go to the generate section and select this first option, constructor. Okay. And as you can see, this dog class's constructor now is calling the parent class animals constructor with the 4 arguments. And we can do the same for the fish class as well. Since it's a must, we need to generate the constructor, because only the constructor can call another constructor by using this or super keywords. Okay. So what that means is that right now in the cat, dog, and fish classes, we do have a constructor. So when I create the objects from those classes, I will be able to set the instances as soon as the object is created. Okay. So this is how we can use the super keyword to call the parent classes constructor. We are going to talk about the types of inheritance in Java. So there are 4 types of inheritance in Java. We have the single inheritance, hierarchical inheritance, multi-level inheritance, and plus multiple inheritance. Okay. So the single inheritance. First of all, single inheritance means subclass inherits the feature of one superclass. Okay. Whenever a subclass is only inheriting from one parent class, one superclass, then there is a single inheritance relationship between that parent class and that subclass. Okay. For example, if there is a class that is named person and this person class is extended by one class only, which is student, then the relationship between the inheritance relationship between person and student would be the single inheritance. The type of inheritance between them is single inheritance. So person is the parent class and student is the child class. And this is a single inheritance. And next we have the hierarchical inheritance. Hierarchical inheritance means one class serves as a superclass for more than one subclasses. Okay, that is what hierarchical inheritance. In another word, one class is being extended by multiple classes. Okay, so if one parent class is having two child or more than two child classes, then it is known as hierarchical inheritance. Okay, for example, if we have this person class and this person class is extended by student and employee both, that means person is the parent class of student and employee classes. Okay, so student and employee, those two classes are the child classes of the person class, and the inheritance type here between those 3 classes would be hierarchical inheritance. And then we have the multi-level inheritance. So the multi-level inheritance means the subclass inherits from a superclass. First of all, one subclass inherits from superclass, and at the same time, the subclass, it also acts as the superclass to the other class or to the other classes. Okay. So if one class is inheriting another class, then that means there is a parent and child relationships. But if the child class is also inherited by another class, if child class is inherited by another class, then it is known as multi-level inheritance. Okay. For example, here you see we have this person class, which is the parent class of employee. And this employee class, which is the child of person, now it becomes the parent of teacher. So what that means is that person is the parent of employee class and employee is the parent of teacher class. Okay. So this is the parent and this is the child, and this teacher is the grandchild class of person. Okay. So this inheritance type is known as multi-level inheritance. Even the child is the parent of other class is what multi-level inheritance is. Okay. And then lastly, we have the multiple inheritance. In Java does not support multiple inheritance with the classes. We do have multiple inheritance in Java, but with the classes, it's not supported. Soon in the future, you will learn interfaces, and interfaces, Java does support multiple inheritance with the interfaces, but not with the classes. So what that means is that when you have one class cannot have more than one superclass. Okay, and inherit the feature from all the parent class. It's not possible. Okay, so whenever one class is trying to inherit multiple classes at the same time, then it is going to give compile error. For example, here we have this class alien and we also have class person. So this employee class, when it extends a class, it can only extend one class only. It cannot extend more than one class. So when this employee class extends a person class, it would compile. But when it tries to extend the second class, alien, then it will give compile error. So multiple inheritance is not allowed with the classes. Okay, Java does not support multiple inheritance with the classes, but with the interfaces, it is possible. It is doable with the interface, not for the classes. In other words, one class cannot extend more than one class, but one class can be extended by multiple classes. We are going to talk about the field hiding in Java. So field hiding, It occurs whenever there is inheritance relationships between the classes. Okay. The precondition for field hiding to occur is there has to be inheritance between two classes. And it occurs when the subclass declares a variable. Okay. It declares a variable with the same name as the inherited variable from its superclass. If parent class already had that variable and subclass still declares it and assign, let's say there will be some new data will be assigned to the variable of that subclass object, then what happens is the variable that will be inherited from the superclass will be hidden in the subclass. Okay, so that is called field hiding. Okay, and subclass, it can still use the super keyword to access the hidden fields of the superclass. Okay, so whenever the subclass has the variable that is having the same name of the inherited variable, so the inherited variable will be hidden, and subclass, it can still use the super keyword to access the value of the hidden variable. Okay, for example, suppose that there is a parent class and it contains this variable a in it. First, we assign a 10 to it as the default value of this instance variable. And when this parent class is inherited to the child class, okay, child class right now is extending parent class, and child class, it declared another variable with the same name a and assigned 100 to it. So this variable a from parent class, it can be inherited to all the child classes, not only to this one. But when it's inherited to this one, in this child class, we have a variable a as well. Okay. In this case, what happens is the variable in the child class is going to be staying as it is, and the variable from the parent class that is inherited to the child class will be hidden. Okay. Because right now the child class's variable, it has the same name as the one that is defined in the parent class. So that's called field hiding in Java.